Hello all. Today we discuss about time domain response of a control system, the first order, second order system. And first of all, we discuss about what is a transient response and the steady state response. The transient response of a system means where the output is changes with respect to the time. This is called the transient response or the dynamical response of the system. And the system goes to the steady state response when there is a no fluctuation of the output. That means there is a no variation of the output with respect to time. So that means these are, say for for the example, this is a timing, and this is the input signal. This is the magnitude of the input signal, and this is CT is basically the output signal. Say for the output signal is variation look like a, and there is a steady state after the time. So before the steady state time, there is a total time where the signal is variations, the output is varies with respect to time. This nature is known as the transient response, TT, transient or dynamical response. And if there is the no change in the output, this is called the TSS, that is steady state condition. Okay, and so now the total time in a transient response is basically transient plus steady state response. These two time response are the total time response of any first order and second order system. And one thing should be remembered, that there is a some signal pattern which is applied in the first order time domain signal, like a delta function, unit step function, ramp function, and parabolic function also. Okay, the time response of a control system means as to how a system behaves in accordance with the time when the specified input signal is applied. Specified input signal means this type of signal, that means either step signal, that is ut, or either ramp signal, that is RT, that is equal to t, ut equals to 1 for t greater than equal to 0. This is also equal to 0 because all are the causal system. We only consider the causal system. This is t square for t greater than 0, and delta t equal to 1 for t equals to 0. These all are the test signal or the signals by which we are applying the input of the any circuit or any control system, first order or second order circuits and or network, and analyze the output with respect to the variation of the output with respect to time. This type of behavior is known as the transient response or time domain response analysis. Why it is so important? Because using this time domain analysis, we can analyze the system, how the system will be first reaching the steady state condition, or how the system delayed to reach the steady state response from the transient response. This type of behavior I study using the time domain response. Okay, so first of all, one thing should be remembered, that for open loop control system, if we consider here one GS block and the gain is 1 by ST, where S is the Laplace coefficient and T is the time constant of the system. This time constant is arises from the CR circuit or LR circuit, the time constant features. But here we apply all in a Laplace domain. So basically CS by R is equal to 1 by ST. Now if we apply here the unit step signal, that is US, so what is the Laplace transform? Yes, right, 1 by S. So now CS equals to 1 by S this, and this RS. So now there is a 1 by S square into T, and that's why we look that the CT is equals to 1 by S square. T means 1 by T. This is equal to T, that is this is the ramp function. Okay, so if we apply here unit step function for the first order system, this is a ramp function. So it is not a controllable parameter because there is no feedback is present. Now if one feedback is present in this circuit, say example for this circuit, there is the same gain ST and one loop feedback, gain 1, and here RS, and here should be negative feedback. This error signal between the input and the feedback signal. This error signal is continuously checking if there is an error signal generation comparison with respect to the input and the feedback signal. So here in this circuit or network, GS divided by 1 plus GS into HS so 1 divided by 1 plus st. Okay, so now this is a total output response of the Laplacian domain. Now here again we apply unit step function here, so therefore Cs equals to 1 by s st plus 1. Okay, so now using partial fraction method we can write this equation in this form also. Yeah, okay, is it right? So there is an so there this after this LCM there is an st and there is a t all to. Okay, so now 1 by s, this is expressed by s 1 plus t. So now if we inverse Laplace of this function, the e 1 minus e to the power minus t by t, because 1 by s the inverse Laplace is unit step, that is 1. And what is the Laplace, inverse Laplace of this function? Yes, right, e to the power minus at. So e here 1 by t. So now we look here that what is our error function? Et is equals to basically rt minus ct. Okay, so now 1 minus e to the power minus t by t, so this error signal is basically e to the power minus t by t. So it looked like that. And what is output response? This look like that. This is a transient nature, so after some time it is the output is constant. Okay, so when before constant, this is the nature of transient nature, and before it is steady state, this is known as the steady state nature of the first order system. Why it is known as the first order system? Because there is only one s in the denominator side, sorry. That is, after we get the transfer function, here we see that there is a one pole exists. This is a pole zero concept. In the later video we will discuss about thoroughly concept about what is a pole zero. Okay, what is a pole zero concept in a control system? This is a very important, either pole in a right half plane or in the left half plane, to determine the system is stable or unstable system, how the system will be stable. And it is also analyzed for the filter circuit also. Okay, so now student, in this video I mentioned in the unit step function. It is your homework, please you study that. If we apply here delta function or ramp function, so what will be the output response? It is your homework. Okay, please do it yourself. Okay, so now we discuss about the concept about the time response of a second order system. This is a very important. Second order system is a very there is a two pole existence of the system, and one thing should be remembered: for a second order system, the typical expression of the open loop gain is omega n square divided by s into s plus 2 zeta omega n. This output cs, this input rs plus minus, and there is a unitary feedback. So what is omega n? This omega n is called undamped natural frequency. This zeta equal to known as damping factor and is equal to Laplace coefficient. Now if we taking cs by rs, okay, so now taking cs by rs, gs divided by 1 plus gs into hs. So after some mathematical computation we get this from 2 zeta omega n is plus omega n square. So this is the second order system. That's why there are two poles are exist, because in the denominator the maximum power of the s equal to 2. That's why here two polar exist. Okay, so now if we study about now we apply here input equals to unit step function, that is equal to 1 at t greater than 0, that is time causal function, not anti-causal system. This is a totally causal system. So after some mathematical computations, okay, we will get the form. The final expression is ct, and apply the inverse Laplace also. So now ct equals to 1 minus e to the power zeta omega n t. In this video I will not show the proper calculation. Okay, I just jump here and show the final expression. This is a zeta square to t plus tan inverse 1 minus zeta square by zeta. Okay, so this is our expression, sin omega into t. Okay, so now from here we calculate our different types of parameter, say et equals to, basically we already know that this rt minus et. Okay, so just et equals to only this part. So here we apply also ess, our steady state error, that is limit t tends to infinity, that is t tends to infinity of this et signal, this measurement of the steady state signal also. And the second order system, after this feedback, the second order system is look like that. If this is considered the unit step function, then the system behavior is look like that. Okay, so there are some parameter which will be studied, that is this time where 0 to this value, this is a rise time, this is a peak overshoot from the input, and this is a settling time. After this is a transient in nature, this is a tss, this is a transient nature. Okay, so lots of parameter, rise time or delay time, and there are some parameter also peak overshoot. Okay, so this parameter calculation, that is rise time, peak overshoot, mp, tss, these parameter are very important to analyze the second order system. And if we changes the damping factor zeta, then how it is relate with the tr and mp and tss. So this type of factor depend on the eta, and this zeta value is depend on the system parameters like a c and r constant. So if we changes the system parameter c and r, then output response automatically changes. So that's the reason to study the properly the control system in a second order system, because in a second order system there are some applications which applicable in a electronics amplifier, feedback amplifier, like a to increase the stability of the amplifier, how to stability of the amplifier, or how to increase the stability of the particular second order system. That's why these signal output parameter like a signal tr, mp and tss study is very important. So in this video we just talk about the first order and the second order system, in the overview of the first order system and the second order system just. And there are the parameter calculation, the individual parameter calculation will be shown in the next video. Okay, because the calculation is very lengthy, that's why in this video we only show the overview picture of what is the significance of the time domain response. Okay.